Hello. Today, let's start with a question. Can AI coding tools truly increase productivity tenfold? You might have many thoughts. Of course it does. Our team was exactly somewhere in between. What we will present today is not an answer, but a record. I'd like to show you the journey that a backend server development team has experienced over the past 10 months. Let's see where the story began. We were not the ones who started it. It was a company-wide direction from LY Corporation. In 2026, LY Corporation defined its mission as wow our users and simultaneously introduced three core values. One of them was 10 times faster. It was a value emphasized directly by our CEO, Idezawa, and our CPO, Shin. In February, posters saying 10 times faster were put up all over the KyoHO office. Every time I came to work, I would pass by this poster. Honestly, when I first saw the poster, I had many concerns. We also thought we were working quickly using AI. 10 times, is that even possible? My initial thought was, this seems difficult. Perhaps there are others who feel similarly. Therefore, we decided not to complain or speculate, but to measure it ourselves. We measured how much our team changed over the past 10 months. As a result, per-person hourly productivity increased by 9.24 times. It was much closer to 10x speed than I expected. The moment I saw this number, I thought, I must share this. That is the starting point of today's presentation. There were many other great sessions prepared on how to use AI. We will share the results of how our team has evolved in response to advancements in AI methodologies. Then, let me briefly introduce who we are, the ones who will be telling you this story. All presenters are Line Plus Line Home backend server developers. Our team is building Content Spectrum, an in-house platform. AI-powered content search for Line Home. It provides classification analysis. We will proceed in three main acts over 30 minutes. In the first act, we will discuss what we measured to arrive at the number 9. In Act 2, I will explain how we established the three conditions that led to these results. In Act 3, we introduce a 4-week plan that you can immediately follow. I have included supplementary materials in the final appendix, which you can refer to after the presentation. Then, we will begin Act 1. The topic is what we measured. First, I will explain 5 terms that appear repeatedly. The first is story point. It is a value that the team has agreed upon as a score for the size of the work. The key is that it's not about time, but the relative size of the work compared to the team's capabilities. Initially, we tried to measure productivity improvement using story point, but there was a problem. As our team's capabilities continue to grow with AI, the amount of work we handle for the same 3 story point task has completely changed compared to a year ago. So what we created is the second term, WWP. It is a unit we directly define by multiplying the amount of code that influences the story point structure, the complexity of the specification, and the burden of verification. It was created to compare the 5 stages of work, which I will explain in the next chapter, using the same criteria. Third, development done is the time from when a JIRA ticket development begins until it is merged. We narrowed down the scope to measure this independently of QA or deployment schedules. The fourth, context engineering, is the technology that determines what information to provide to the AI. Finally, harness engineering is a technology that binds AI, like a bit and bridle, to control its direction. The explanation of harness engineering has been covered extensively in other sessions today, so if you missed it, please refer to the video later. These two terms are directly connected to the two breakthroughs I am about to discuss. This is the scope we measured. Leverage tickets completed over 10 months. I directly tallied the merged PRs for the ticket commits. Face line. Prompt context, agentic harness. We divided the work process into 5 stages based on different periods. We applied methodologies that received a lot of attention during that period. I have summarized the stages of how we changed the way we work on one slide. What I really hope you remember from this is, each stage is cumulative. Each stage builds upon the capabilities of the previous stage, adding new capabilities one by one. The baseline was when we coded directly without AI. We added the ability to fix code by asking the AI one by one in a conversational manner during the prompt stage. In the context engineering phase, we used various documents, including claw.md. We were able to delegate the project understanding itself to AI. This is our first breakthrough. We added autonomous delegation and concurrent processing to the agentic stage. However, as autonomy increased, so did the burden of verification. In the final harness engineering stage, we added a verification and management infrastructure on top. This is the second breakthrough point. Before I tell you the results, there is no separate standard for measuring AI development productivity. We created and measured a unit called WP, which I mentioned earlier. A detailed explanation of this unit is included in the appendix, so please refer to it later. Over the past 10 months, we have introduced AI tools and transformed our way of working. The per person, per hour productivity increased by 9.24 times, which is more than 9 times. This number is easier to understand if we break it down into 3 parts. First, the time it takes to process one chunk of the same weight has been reduced by 2.79 times, and the amount of work one person processed in a month increased by 3.31 times. Multiplying these two means that the amount of work produced by the same person in the same amount of time increases 9.24 times. This time, we've laid out the monthly trends across 4 metrics. Starting from the top left, clockwise, the sum of WWP of commits per month. This is the throughput per person based on the number of completed story points. The background color of the chart shows 5 stages divided by period. The key is that all my metrics show an upward trend in the same direction. However, every time we changed our way of working, it wasn't always for the better. In the context engineering stage, the information that could be conveyed to the AI was limited, so progress stagnated for a while. In the agentic phase, we ended up handling too many tasks simultaneously. As a result, the throughput dropped because it exceeded the scope that humans could review. And my metrics simultaneously peak in April. This is the effect of the harness engineering breakthrough. Looking at the numbers alone, 9.24 times seems to be the most striking. However, there was another change that we felt was truly valuable. The size of the problem that the team can handle and the way we define work has changed. Before its introduction, the backend server focused on simple tasks, while the front end was not properly developed and only partial testing was conducted. The completion criteria were also very ambiguous, to the point where the median was the limit. But now, Even though we are a backend team without a front-end developer, all developers on the team are now able to handle UI front-end and backend for large domains. Additionally, all code and documents generated by AI were automatically verified. The median number of conditions completed in one attempt also increased from 1 to 3. What we do has become clear. It's not just about getting faster. So we refined the definition itself. So how did we achieve this change? Now, Lin Hyo will continue the presentation. Hello, I'm Lin Hyo. In Act 1, what Shin measured, and you've summarized what 9.24 times means, haven't you? So now let's move on to the most important question. How exactly were the results created? In Act 2, I will explain the 3 conditions that enabled a 9x efficiency improvement one by one. I have gathered the 3 conditions I just promised on one slide. The first is context engineering. With Claude.md and module documentation history, this is an environment that explains our team and project to the AI. This is the first breakthrough, which we achieved in November of last year. Second is harness engineering. Second, verification, skill document. This is an infrastructure that safely supports autonomous delegation with these 4 pillars. This became the second breakthrough point in March of this year. Third, we refined the work definition, which is work definition refinement. This clarifies the requirements and completion criteria. The number of completion conditions increased from 1 to 3 based on the median, allowing us to assign larger domains. This happened almost simultaneously with the second breakthrough. It can be seen as a natural progression. Then, I will sequentially show you how these 3 conditions were created. These are the stages we have been through. Baseline prompt. Context agentic. Harness engineering, like this, there are 5 of them. However, the real change occurred not in these 5 stages, but in 2 breakthroughs between these stages. The first breakthrough was in November of last year, when moving from a prompt to context engineering. We created and refined Claude.md. After providing the AI with the project's rationale and work history in a single document, even with the same prompt, the efficiency jumped by several times. AI is... It was the moment when it transformed from a simple auto-completion tool into a colleague we could entrust tasks to. What we did for the first breakthrough was surprisingly simple. To AI, create a one-page document explaining our team, and we prepared a command that automatically records work history. What you see on the screen is part of Claude.md, which was introduced in November of last year. The project overview includes things like the 7 module structure, code conventions, and commit format for content spectrum. We made the AI automatically read and start this for each session. And with skills, we also automated the recording of the AI's work history. For example, if you type the dev start command, starting with the tickets and branches, they were made to write a development plan document. I had them write a planning document, and by doing this, the AI now understands the goal and progress of each ticket for every task. As a result, the history of planning and developing each task, along with the code, was documented. So AI. As it reads automatically, the code being generated has changed. Ticket throughput also increased, and ticket throughput, the task processing time, was also slightly reduced. The amount of work processed in a month also slightly increased. However, What's interesting is, the code output itself actually decreased for a short period, from 34,000 lines to 20,000 lines. It has dropped by about 39%. However, the tickets processed during the same period, it increased from 25 to 32. What this means is that unnecessary code has been removed, and the proportion of proper code has increased. This is the first breakthrough point. It's not AI tools that brought about change, but rather context engineering. The reason for the additional verification in harness engineering is explained by this 60-file incident. It was March of this year, and we were actively increasing the number of self-reams in the AI GAC phase. While doing a PR review, the agent asked me to review 60 files in a legacy area that should not be touched. Humans found that it had been arbitrarily modified. Fortunately, as it was before the merge, there was no operational impact whatsoever. The cost for recovery was about 1 day in total. Although the cost was small, we learned a great deal. We could not control the autonomous agents using only descriptive documents such as Corda Envy. As an agent's autonomy increases, the burden of verification explodes proportionally. The limitation is that people only review at the final stage. So we reached the conclusion that verification should be moved to the infrastructure. If this had gone through to deployment without being caught in review, it was an incident that could have taken days or even weeks to recover from. The key is that we cannot leave such potential risk to chance every time. As harness engineering was applied, we reached a second breakthrough. After applying harness engineering, the autonomy of AI has increased, but rather, it became safer. The commonality between these two breakthroughs is clear. It's not that we changed AI tools. We changed the way we work. What was our team's conclusion after this incident? It's not about using less AI. It was about creating a structure to measure and verify the results produced by AI. We achieved. We organized the few story point we had into a framework. First, identification, planning, development, verification, delivery, review, release. We divided the flow into 7 stages. We automatically track progress by recording it in YAML. In fact, it is the core of our harness engineering. Second, we created several agents with different personas for each job type, such as code review agents and UI verification agents, for each stage of the process. We mutually review the specifications and development progress. Third, repetitive tasks were standardized with skills or commands. Fourth, it automatically blocks dangerous commands via hooks at each execution stage and verifies plans and results. We did not initially introduce all areas of harness engineering from scratch. We started with variables that were immediately helpful for operations, and we are still using them while continuously refining them. This is the data that resulted from the full-scale introduction of harness engineering. From April this year, as the 4 pillars started to function properly, all metrics compared to agentic, it more than doubled. A verification infrastructure. This is the effect that came about as we started to support autonomous delegation. Among the effects of harness engineering, the most significant was the reduction in processing time for large tasks. A major task moving from agentic to harness engineering. A task that was 8 story points is now 3 times faster. Then why is the effect greater for larger tasks? This is because the burden of verification due to complex qualification tasks is greater. The committee had agreed on the specifications beforehand. Multiple agents automate verification, and this is the result of standardizing skills and having the post-stabilization role verify large tasks, which reduce the burden of verification. Now, Janook will take over and present a 4-week plan that other teams can also follow. Hello? In the last part of our presentation, we will show you the 4-week plan from week 1 to week 4. To which teams can it be applied? After organizing the conditions, I will now conclude with a single message. The fastest way for an organization to change is for one person to experience it directly. One person, starting next week, you can become. We know it's good, but how do we start within our team? As you've been listening, this thought must have crossed your mind. I would like to share the quickest way to experience productivity improvement. From now on, I will show you the 4-week plan. It's about directly applying it to your own work. Please don't wait to persuade an entire organization or for large-scale adoption. That can be done right now. It would be good to start with the smallest part. The first week is a stage where not a single line of code is touched. To AI, our team, and explaining the project. We're trying to create a Claude.md initially from 10 lines. 15 lines should be enough. Based on that, to AI, what is the purpose of this project? Where is this method called from? And similar read-only questions, module structure, and we also try to organize the coding conventions together, but we do not change a single line of code. The safest starting point and time is 2 to 3 hours are sufficient. In weeks 2 and 3, we applied AI to the area of modifying documents and metadata. Automatically writing documents or readmes, creating a commit message, whether we use Jira commits or not, or changing the ticket status. It's about automatically generating PR content. All of these parts are safe areas that do not affect the operating code. In the process, we began extracting 1 or 2 repetitive tasks as skill commands. This is the stage where the team's skills are established. It would take about 10 to 20 hours. The risk is still low. In the 4th week, we expanded into the code area for the first time. However, it's not about autonomous delegation, but rather reviewing and approve in a workflow format. A safety net will be in place. You shouldn't just say, do it yourself, person. After organizing the requirements, the AI creates a plan. Someone approves once. Also, if AI develops, a person approves it again. Then, it goes through a code review and is merged. Because a human had to pass through the gate twice, a small PR, it's a good idea to start with 1 or 2 cases. It takes about 20 to 40 hours. The risk level will increase to a moderate degree, but such gates provide stability. I'll briefly explain ROI, but please refer to the appendix for more details. A team of 5 people, based on 6 months. We are assuming that the entire team invests about 1.5 weeks per person in the first month. Then, for the remaining 5 months. Even if we only achieve double the efficiency, the organization grows to be able to do the work of 1 or 2 more people. Our team actually invested up to 9.24 times, but we conservatively reflected only 2 times in this calculation. What are the criteria for continuing or stopping work when applying harness engineering or workflows? You can adjust it to fit your team's characteristics. To which team is this applicable? That's the most frequent question we receive. I have organized it based on 5 criteria. What are the recommended conditions? From 2 to 10 people. The project has multiple modules with clear boundaries. To avoid, there is a ticket workflow like Jira. There are no issues with utilizing Frontier LLM. It's good if it's a team where a PR review culture is well established. Our team, under these conditions, we apply AI tools sequentially, and then we were able to achieve results by changing our work methods. Conversely, I will frankly discuss cases where application is difficult. A one-person team or a large organization with over 50 people, monolithic projects with unclear boundaries, PR, or in cases where there is no ticket workflow at all, or an environment where it's difficult to use frontier models because there's no enterprise contract, and the culture of pushing directly without review. If this is the case, rather than immediately reviewing the adoption of AI, we focused on changing the team's constitution. I think it would be better to improve that first. Unconditionally, our team's 9.24 times. This does not mean that you can simply take it as is. The more conditions are met, similar, this means that we can expect an effect. Would you please summarize this for us one last time, Hongju? This is Hong Jung again. I will summarize today's presentation in one sentence. A tenfold increase in AI productivity is not the result of merely adopting AI tools, but rather a re-engineering of our working methods. Tools such as Claude Code, Copilot, and Codex were all equally available in the market. The reason for the divergent results, even with the same tools, is there was an environment created by our team around the tools. We will create an environment called Context using Claude.md. Through harness engineering, the team directly created and applied a validation environment. We were able to increase productivity. If you don't change the environment, the tools won't change. Our entire team understands AI and embraces it like a colleague. We deliberated together. At that moment, AI is not a tool that receives commands, but we have become colleagues who make decisions together. The result: productivity by 9.24 times, 0 outages for 10 months. Hot fixes returned to less than once a month. There was something Mr. Itazawa emphasized. AI, cool, but a team member. We need to redesign our entire work process by incorporating AI from the beginning. I believe that only when these words become a reality can we achieve a 10x speed improvement. It's about embracing AI as a team member and redesigning our workflow from the ground up. If that's not presupposed, a 10x speedup remains just a claim. Our team's case is about when a team's words actually became a reality. It was a record showing what had happened. Are you just using AI as a tool, or just giving commands without context? If you don't have an environment to verify, now is the time to re-examine it. Try working with AI not as a tool, but as a team member. You can start right now, not in the distant future. Thank you.